Hi there, and welcome to this short clip on how to do mole equations without triangles. So basically what we're looking at is how to rearrange them because you know how to, not just because it says so in a triangle. So you've probably been taught how to make something the subject of an equation. You've probably maybe even seen these mole triangles before and realised that they're quite convenient, they're quite helpful. But do they actually teach you the maths? So what we're aiming to achieve with this clip is to set you on a journey so that you actually do know the maths behind them. So you don't necessarily need triangles anymore because you can actually work it out for yourself mathematically. So let's look at moles equals mass in grams over molar mass in grams per mole to the -1. Now depending on whether you're dealing with atoms or whether you're dealing with molecules, it can come in two forms. Moles equals mass over mR, as you have in the formula triangle there, or moles equals mass over AR. So let's have a look at how we might actually rearrange this without using a triangle. So take the example of needing to work out the mass. This would be a situation where we have the moles and the relative atomic mass, but not the mass. So in this case, you multiply both sides by the denominator in the expression to cancel it. The denominator is the molar mass. So if we multiply both sides by the molar mass, you can now cancel out the molar mass on the right hand side. That gives you moles times the molar mass equals the mass, which is the same as what the triangle tells us up in the top left hand side of the screen. But we did that without having to use the triangle. We did it using mathematical means. Let's have a look at another rearrangement of that particular equation. So let's say this time we wanted to actually work out the molar mass. We didn't know what it was. But we had the moles and we had the mass. This is a bit more simple. The subject and the denominator can be swapped, like so. So mR becomes mass over moles. mR is now the subject. So let's look at the units for a minute or two. The unit of mass is grams, the unit for moles is mol, and the unit for molar mass is grams per mole to the -1. Where did the -1 come from? The molar mass is mass over moles equals grams divided by moles. So what you want is to express the grams per mole. You want the mole to read next to where it says grams. To do that, you have to inverse it. In the same way that 1 over x equals x to the -1. So let's start with n equals c times v, where n is equal to the moles, c is equal to the concentration in moles per decimeter to the -3, and volume equals decimeters cubed. So let's say we were doing a question. So this one, first of all, is easy because the subject is moles. So therefore you don't have to rearrange anything. So remembering to convert centimeters cubed into decimeters cubed, it's simply 2 times 30 over 1,000, which gives us 0.0600 moles. Now let's look at an example that actually requires us to rearrange the equation. So looking at the question, let's identify what we're meant to work out. So it asks us to calculate the volume, but the volume isn't the subject. So we have to rearrange so the volume is the subject. So what's volume multiplied by? It's multiplied by concentration. So divide both sides by concentration to isolate volume, like I've done at the bottom of the screen. Now you can cancel. So you cancel the concentration, and the only place you can do this is on the right hand side of the equation. This now gives us a new equation we can use, which is V equals N over C. Now if you look at the rearranging the formula triangle at the top left of the screen, you'll see it's exactly where that came from. But we've just done it because we know what to do mathematically, not because we pulled it out of a triangle. We can obviously now put the figures in to help us complete the calculation, which means we now have 0.0203 decimeters cubed, or 20.3 centimeters cubed. So how did we get the units for volume? If you look at the equation, and when I put the numbers in black, you'll see I've added the units. They can also be cancelled. So that gives us 1 over decimeter to the minus 3, which gives us decimeter cubed. It might also be worth spending a moment looking at the origins of these units so we can fully understand why we actually have decimeter to the minus 3. So if we put in the standard units for each of the components of the equation, let's have a think about where moles per decimeter to the minus 3 comes from. To do this, we need to make concentration the subject. So doing exactly what we did before, we cancel volume, giving us C equals N over V, equals moles divided by decimeter cubed. So if we want to write this in a linear fashion, what we have to do is inverse the decimeter cubed. All we've done here is exactly the same as if we had 1 over x. We change it to x to the minus 1. So we've changed decimeters cubed to decimeters to the minus 3. So, here's another one that you might come across from time to time. How to convert between moles per decimeter to the minus 3 as one unit of concentration and grams per decimeter to the minus 3 as another unit of concentration. The key is in the relationship between moles and grams. So going back to an earlier point in the video clip, we said that moles equals grams over grams per mole to the minus 1. In other words, mass over molar mass. So it's reasonable to say that moles per decimeter to the minus 3 would be equal to grams per decimeter to the minus 3 over grams per mole to the minus 1. How do you make grams per decimeter to the minus 3 the subject? So you multiply both sides by grams per mole to the minus 1, which allows you to cancel. So grams per decimeter to the minus 3 is moles per decimeter to the minus 3 times molar mass, which can also be written like that. It's just a matter of rearranging the units. So now let's have a look at a slightly more complex one. This one comes up later on in the first term of your A-level chemistry course, and it's called the ideal gas equation. So this one has 5 components. So in this equation, P is pressure, V is volume, N is moles, R is gas constant, and T is temperature. I'm not going into the units. I'm not even going into what each one means that much. I'm actually just going to focus on how to rearrange it. So the trick is to pair up what's actually in the equation together. You take everything else and you try to treat them as 2 separate expressions instead of 4, which gives you nRT equals V. Same thing for V. V equals nRT over P. So solving for N, it's PV over RT. And for t, it's PV over NR. So the key to doing this is, first of all, isolate the subject. And secondly, you pair the components that are already multiplied. If you look very closely, you can see that RT, for example, is always kept together. You can see that wherever possible, PV is kept together. You can see that NR is kept together. Okay, so hopefully this has been a reasonably useful clip to introduce you to how to rearrange equations without using triangles. Obviously, if you have any queries, please do bring them into college and have a talk to one of us on a subject extension, or maybe have a chat to your teacher. But in the meantime, bye for now, and thanks for watching.